From a piano to a choir to a whole orchestra, how is it that all of these instruments can play and sound perfectly together? Well, it doesn't happen by coincidence. It all comes down to tuning and the physics that's behind it. First, we have to look at what sound is. Whenever you play or sing anything, you're creating vibrations, whether it's from a reed, string, or your vocal cords. These vibrations push particles in the air, creating patterns of high and low pressure that travel all the way to your eardrums that your brain interprets as sound. And we can visualize these waves in lines called sinusoids. Now that we know what sound waves are, how does this help us with music? Every musical note we play is defined by its frequency, which is how many vibrations happen per second. So air that's vibrating faster will result in a note that's a higher pitch, and air that's vibrating slower will result in a lower pitch. For example, to play the note C, your sound vibrates at 261.6 times per second, which can be represented as 261 hertz. Now let's put C with other notes and their respective frequencies in what's called an octave. In any given octave, there are 12 notes that repeat higher and lower. Now that we know what all the notes are, let's see what happens when we try to play the same note together. Wait, we're all playing the same note, so why does it sound so wonky? And how do we fix it? Well, here's where tuning comes into play. Going back to the piano, let's use an example to see how tuning works. Modern tuning centers around the note A because it plays at a perfect 440 Hz. So we'll use this and the note right above it, which is B flat. If we play these notes at the same time, we're going to hear beats from every time the slight differences in frequencies overlap. We can calculate the frequency of these beats using this simple formula. Now here's the cool part. Let's see what happens when we lower the frequency of B flat until we get to A. There it is. So the closer you get to the note you're going for, the less beats we'll hear. And that's how you tune a note. Of course, you won't be a whole 26 Hz off the note you're playing. You'll naturally be about 5 to 10 Hz above or below the note. And through the use of tuning apps, pitchforks, or simply doing it by ear, you can hear and see the ways that you can lengthen or shorten the vibrations to get your notes to the right frequency. So using everything we learned so far, we can get an ensemble that sounded like
Ready, and
separated and out of tune to this,
ready, and
aligned and perfectly together. So whether it's a single instrument to a choir or a whole ensemble, tuning is all about getting everyone's vibrations to match. When the waves line up, the sound locks in, and that's the physics behind tuning.